called as run length encoding. Okay, when we are use the run length encoding is nothing but this type of encoding is used when the source information comprises the long substrings of the same characters, okay, or some binary digit. So here, instead of transmitting the source string in the form of the independent code words, it is transmitted in the form of the different set of the code words. Okay, so different set, how it will be transmitted ಅಂತ ಅಂದ್ರೆ, so one example we have. Okay, so for example, so when scanning some particular document, the scanner will produce the long substrings of either binary zeros and ones. Okay, so scanning, how it will take, so this is actually you know it in the module 2. Okay, so scanning the document. Okay, so scanning will take place from top to bottom and from left to right. Okay, each line will be scanned and that particular line will be digitized. So how it is digitized? So digitized is nothing but conversion of the textual information into binary digits like zeros and ones. Okay, so when we have used these type of the scanned document, okay, scanner produces the long substrings of either binary zeros and ones. Okay, here instead of transmitting these directly, okay, when we have the big size file which contains these type of the information, then instead of transmitting these directly, they are sent in the form of the strings of the code words. Okay, how it will be transmitted? So each indicating both bits 0 and 1. Okay, how it is done, that will be can see in this below pattern. Okay, so in total number of the bits in the substring example they have given. So some long substrings they have given here: 0 0 0 0 0 1 1 1 1 1 0 0 0 0 0 1 1 1. Now this is called as long substrings of the code words. Okay, so instead of sending this, they are, what they have done here is, so they have make one group, like for 4 bit it is one group, for 3 bit it is one group, for 2 bit it is one group, like that they are going to make the group. Okay, so that group can be represented as 0 7 comma 1 comma 1 0 0 comma 5 comma 1 comma 2, like that. So this is 100, it is not converted into the digit, so it is directly converted into the binary digits only. Okay, so 7 is a digit, so 100 is a binary digit, 5 is also digit, 1 is also digit, 2 is also digit, like that. So here some group they will do. Okay, some group they will do. So this group can be transmitted. Okay, so this information is be transmitted, and what type of the group they have done in the source side, that is information will be shared with the destination end, so that destination will decode the whatever the transmitted bits they have sent in the network. Like that they are going to do in the run length encoding. Okay, so this is one type of the encoding principle. This is one type, run length encoding, how they are going to do, where they are going to do. Okay, so run length encoding is nothing but it is used where when we have the long substrings of the characters. Instead of sending the long substrings of the characters as it is, they are making single groups. Okay, like digits. So like binary digits or some digits, like pattern they are going to make, and what type of group they have made, that information will be shared with the destination side, so that destination and it is going to recover that particular pattern. Okay, so that is called as a run length encoding. Okay, so understood? ಗೊತ್ತಾಯ್ತಲ್ಲ ಇದು? Hello? Hello?
Yes, sir.
Okay, that is run length encoding. So next is statistical encoding antide. So statistical encoding is nothing but in variable length encode, in variable length code words. In order for the decode operation to be carried out correctly, it is necessary to ensure that shorter code word in the set doesn't form the start of the longer code words. Otherwise, coder will interpret the string on the wrong code boundary. Okay, so ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ statistical encoding ಅಲ್ಲಿ, ಸೊ ವೇರಿಯಬಲ್ ಲೆಂತ್ ಎನ್ಕೋಡಿಂಗ್ ಏನ್ ಮಾಡಿದೀವಿ ನಾವು ಆಕ್ಚುಲಿ, ಸೊ ಈ ತರ ಗ್ರೂಪ್ ವೈಸ್ ಸೆಂಡ್ ಮಾಡಿದೀವಿ. ಓಕೆ, ಸೊ ಈ ತರ ಗ್ರೂಪ್ ವೈಸ್ ಸಮ್ ಗ್ರೂಪ್ ವಿಲ್ ಬಿ 3 bits, some group will be 4 bits, some group will be some other pattern bits, like that we will have. Okay, because of this there is a chance of decoder to misinterpret the information. Okay, ಸೊ ಈ ತರ ಆಗ್ಬೋದು. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಇದನ್ನ ನಾವು ಸ್ಟಾಟಿಸ್ಟಿಕಲ್ ಎನ್ಕೋಡಿಂಗ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಹೆಂಗೆ ಅಂತ ಅಂದ್ರೆ, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕೆಲವೊಂದು ಟೈಮಲ್ಲಿ 3 bits ನ ಗ್ರೂಪ್ ಮಾಡ್ತಾರೆ, ಕೆಲವೊಂದು ಟೈಮಲ್ಲಿ 4 bits ನ ಗ್ರೂಪ್ ಮಾಡ್ತಾರೆ, ಕೆಲವೊಂದು ಟೈಮಲ್ಲಿ ಬೈನರಿ ಡಿಜಿಟ್ಸ್ನ ಸೆಂಡ್ ಮಾಡ್ತಾರೆ. ಈ ಥರ ಡಿಫ್ರೆಂಟ್ ಪ್ಯಾಟರ್ನ್ ಇರೋದ್ರಿಂದ ಡಿಕೋಡರ್ಗೆ ದೇರ್ ಇಸ್ ಅ ಚಾನ್ಸ್ ಆಫ್ ಕನ್ಫ್ಯೂಸಿಂಗ್. ಓಕೆ, ದೇರ್ ಇಸ್ ಅ ಚಾನ್ಸ್ ಆಫ್ ಕನ್ಫ್ಯೂಸಿಂಗ್ ವಿಲ್ results. So to reduce these confusions, we will use the statistical encoding. Okay, this is the one disadvantages which is seen in the variable length run length encoding. Okay, to overcome these disadvantages, okay, we are using the statistical encoding technique. Okay, the code word that set avoids this happening is said to be the possess the prefix property. Okay, prefix property ಅಂತ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಇಲ್ಲಿ. Okay, so the Hoffman coding algorithm is example of such type of the encoding. So statistical encoding is nothing but one example for the Hoffman encoding algorithm anta. So we will use study the different algorithm to compress the text in textual information. So Hoffman encoding algorithm is also one type of the algorithm. Okay, that you will see in the next coming topics. Okay, of what is Hoffman encoding algorithms, how it will be coded the textual information. Okay, how it will be compressed the information, and we are going to see in the coming topics. So the Hoffman encoding is, this is one topic which is a one algorithm which is used in the compression principle. Okay, so why we are using this statistical encoding means to avoid the confusions, confusioning confusion which is happening to the decoder. Okay, how we are going to avoid antandre by using the prefix property. Okay, what is the prefix property antandre? So some prefix use ಮಾಡ್ತಾರೆ. ಸೊ ಅದಕ್ಕೆ ಗೊತ್ತಾಗೋ ಥರ. ಓಕೆ, ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಏನು ಮಾಡಿದ್ದಾರೆ, ಥಿಯರಿಟಿಕಲ್ ಮಿನಿಮಮ್ ಅವರೇಜ್ ನಂಬರ್ ಆಫ್ ದಿ ಬಿಟ್ಸ್ ದಟ್ ಆರ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಟ್ರಾನ್ಸ್ಮಿಟ್ ಎ particular source stream is known as a entropy of the source. Okay, so they have finding out the entropy. Okay, so what is the minimum average number of the bits that are required to transmit the particular source stream? Okay, that is called as entropy of the source, and it can be calculated by using this formula: h is equal to minus of summation of I 1 to n pi log 2 of pi, where p is the probability of the occurrence of the symbol. Okay, probability of occurrence of the symbol. Okay, and n is nothing but number of the different symbols in the source stream. Symbols ಅಂತಂದ್ರೆ it may be characters ಇರಬಹುದು, ಅಥವಾ it may be some binary digits ಇರಬಹುದು, ಅಥವಾ it may be some digits ಇರಬಹುದು. That is called as symbols ಅಂತ ಕರಿತೀವಿ. So to calculate the entropy, they are going to do this statistical encoding. So entropy is nothing but how many number of the average number of the bits that are required to transmit the particular source information, that can be calculated by the entropy of the source, that can be calculated by using this formula. Okay, then we need to find out the what is the average number of the bits per code words. Okay, when we have the code words, so what is the average number of the bits per code word? It can be calculated by summation of I to n ni pi. So n is nothing but number of the symbols. Okay, p is nothing but probability of occurrence of the that particular symbol ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲಿ it may be some characters ಇರಬಹುದು. ಇಲ್ಲಿ probability of occurrence ಅಂತ ಅಂದ್ರೆ how many times it is repeating ಅಂತ. For example, a ಅಂತ 4 ಟೈಮ್ ಇದೆ ಅಂತ ಅಂದ್ರೆ probability of occurrence of a is nothing but 4 ಅಂತ ಅರ್ಥ. Okay, if b is b ಅಂತ ಇತ್ತು ಅಂತ ಅಂದ್ರೆ probability of occurrence of b is 2 ಅಂತ ಅರ್ಥ. Okay, so that is called as probability of occurrence ಅಂತ ಕರೀತಾರೆ. Probability of occurrence ಅಂತ ಅಂದ್ರೆ how many times the characters are repeating, same characters are repeating ಅಂತ. So for a ಅಂತ 4 times ಇತ್ತು ಅಂತಂದ್ರೆ probability of occurrence of a is 4 ಅಂತ. If f ಅಂತ ಇತ್ತು ಅಂತಂದ್ರೆ 2 times, so the probability of occurrence of f is 2 ಅಂತ. So if by g ಇತ್ತು ಅಂತಂದ್ರೆ probability of occurrence of g is 3 ಅಂತ ಅರ್ಥ. So like this we will have the probability of occurrence of the symbols. So that is called as the probability of occurrence. So using this they are going to find out the average number of the bits per code word. Okay, this can be calculated by using this formula. Okay, so by doing this entropy and this average number of the code words, we will have able to send the code words. Okay, in terms of prefix. Okay, they are going to use prefix. So for one group they are going to use one prefix, for another group they are going to use another prefix. Prefix is nothing but to identify the particular group. So that is called as a prefix property. So that is used in the statistical encoding. So we have the disadvantages in the variable length encoding. Okay, so to overcome that disadvantages, we have used the technique called as prefix property in the statistical encoding scheme. Okay, How they are done antandre using all these finding out the entropy and average number of the bits that are required. Okay, so using these things, we are going to transmit the statistical encoding. Okay, so that is the concept which is behind in the statistical encoding. This is the one type of the transmitting, one type of the transmitting, which is encoding scheme. Okay, so here n is nothing but number of the different symbols in the source state. Pa is nothing but probability of occurrence of the symbol. Okay, so this is about the statistical encoding principle. Okay, next another compression principle we have. So what is that compression principle? Here is the source encoding. Okay, so what is the source encoding? Source encoding is nothing but it exploits the particular property of the source information in order to produce an alternative form of representation. So example, that is either compressed version of the original form. So this is one type of the compression principle, source encoding. Here what they are going to do, they will exploit the particular property of the source information. Property is nothing but it may be some amplitude level ಇರ್ಬೋದು in terms of image ಅಂತ ತಗೊಂತು ಅಂತ ಅಂದ್ರೆ you can take the property of the image ಅಂತ ಅಂದ್ರೆ you can take color, you can take saturation, you can take amplitude level. For example, in audio it will be amplitude level ಇರ್ಬೋದು. Compression ಅಂತ ಬಂದಾಗ ಆ image ಅಲ್ಲಿ it will be having, we are having some brightness ಅಥವಾ ಕ್ವಾಲಿಟಿ ಆಫ್ ದಿ ಇಮೇಜ್ ಅದನ್ನ ಪ್ರಾಪರ್ಟಿ ಅಂತ ಕರೀತಾರೆ. ಅದೇ ಆಡಿಯೋ ಅಂತ ಬಂದಾಗ ಇಟ್ ಈಸ್ ಮೆಜರ್ಡ್ ಇನ್ ದಿ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಲೆವೆಲ್. Okay, that is also property of the audio. So like that, they will exploit the particular property of the source information to in order to produce the alternative form of the representation. Okay, so that is called as source encoding. We will, here source encoding is nothing but they are going to exploit the property of the source information. Source ಅಂತ ಅಂದ್ರೆ it may be image ಇರ್ಬೋದು, it may be audio ಇರ್ಬೋದು. This is called as source ಅಂತ. So using these source, they will exploit the source information. Okay, so so information ಅಂತ ಅಂದ್ರೆ it is in the form of the amplitude level ಇರ್ಬೋದು, or it is in the form of the some image property ಇರ್ಬೋದು. They're all called as source property. Okay, they are going to exploit that property, and using that property they are going to make the alternative form of representation. So either in the compressed version of the, that is in the version of the original image. Okay, that is called as source encoding. They will exploit the property of the source. Okay, so source may be different for different multimedia, so that property they are going to exploit. So that is called as source encoding scheme. Okay, in this source encoding scheme we have different types. Differential encoding. Okay, so we have the differential encoding ಅಂತ ಇದೆ, and one more thing here is transform encoding ಅಂದ್ಬಿಟ್ಟು. So these are the two different type of the source encoding: differential encoding and transform encoding. So these are the two different types which is come in the source encoding scheme. Okay, next we will see the what is a differential encoding. So these are all the different compression principle which are applied in the multimedia applications. Okay, so these are all some principles which are applied in the compressions. Okay, understood? ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ವಾ? ಹಲೋ, ಗೊತ್ತಾಗ್ತಿದೆಯಲ್ವಾ? ಸ್ನೇಹ, ಸುಷ್ಮಾ, ಸಹನಾ,
Yes, sir.
ಶ್ರೀಧರ್.
Yes, sir.
Okay, so I will tell you about the differential encoding. So what is the differential encoding? The differential encoding is used where amplitude of the value or signal covers the large range, but the difference in amplitude between successive values or signal is relative to small anta. Okay, so ನಾನು ಹೇಳಿದಂಗೆ source encoding ಇಲ್ಲಿ they are going to exploit the property of the, they are going to exploit the property of the source information. So here what source information they are going to use here is the amplitude level. Okay, that is called as one source information. So source information property of the source information. So they are going to exploit that particular property. Okay, that is called as differential encoding. Okay, ಹೇಗೆ ಅಂತಂದ್ರೆ for example, if digitization of analog signal requires 12 bits to obtain a required dynamic range, but maximum difference in the amplitude between the successive samples of the signal requires only 3 bits. So then by using these, only difference value saving of 75% on the transmission ಅಂದ್ಬಿಟ್ಟು. ಸೊ ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂತ ಅಂದ್ರೆ, ಸೊ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಬ್ಯಾಂಡ್ವಿಡ್ತ್ ಕ್ಯಾನ್ ಬಿ obtained. ಸೊ ಏನ್ ಮಾಡಿದ್ದಾರೆ ಅಂತ ಅಂದ್ರೆ, ಡಿಜಿಟೈಸೇಷನ್ ಆಫ್ ಅನಲಾಗ್ ಸಿಗ್ನಲ್ ರಿಕ್ವೈರ್ಸ್ 12 bits to obtain the required dynamic range. Okay, here maximum difference in the amplitude between the successive samples of the signal requires only 3 bits. Okay, and then by using the only difference value of saving up to 75% on the transmission bandwidth can be used ಅಂದ್ಬಿಟ್ಟು. So ಇಲ್ಲಿ ಏನು ಅರ್ಥ ಅಂತ ಅಂದ್ರೆ, so to convert the any your analog signal into the digital, they are going to make the some process. Okay, while doing the process, some 12 bits are required. Okay, to conversion of that signal. Okay, then they will analyze another pattern. So what pattern ಅಂತ ಅಂದ್ರೆ difference between the samples ಅಂದ್ಬಿಟ್ಟು. So amplitude level successive samples, so ಅದನ್ನ ಅನಲೈಸ್ ಮಾಡ್ತಾರೆ. So it is requiring about 3 bits. The maximum difference in the amplitude between the successive samples of the signal requires only 3 bits. ಇದನ್ನ ಅನಲೈಸ್ ಮಾಡ್ತಾರೆ. So when compared to the number of the bits requirement, they are going to analyze the difference between the conversions, one sample to another sample. They are requiring 3 bits there. Okay, there to convert the entire thing, they are going to do the 12 bits are required. Okay, here they are analyzing the difference between the samples. So the difference is requires 3 bits. Okay, so ಈ 12 ಬಿಟ್ ಕಂಪೇರ್ ಮಾಡುತ್ತೋ ಅಂತ ಅಂದ್ರೆ ಈ 3 ಬಿಟ್ಸ್ ಇಟ್ ಈಸ್ ವೆರಿ ಲೆಸ್ ಅಂತ ಅರ್ಥ. ಓಕೆ, ದೆನ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪ್ಲೋರ್ ದೀಸ್ ಪ್ರಾಪರ್ಟಿ. ಸೊ ಈ ಪ್ರಾಪರ್ಟಿನ ಎಕ್ಸ್ಪ್ಲೋರ್ ಮಾಡ್ತಾರೆ. ಸೊ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿ ಸಕ್ಸೆಸಿವ್ ಸ್ಯಾಂಪಲ್ಸ್ ಆಫ್ ದಿ ಸಿಗ್ನಲ್, ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಓನ್ಲಿ 3 bits, and to convert the particular signal it requires 12 bits. So that 12 bits will be they will leave and they will take out the this difference between the successive samples of the signal. Okay, this they are going to take this. Okay, because it is 12 bits, it is in the case of the representation. So the difference between the successive samples now, it is represented in the form of the 3 bits. So these 3 bits, the difference will be taken as a property of the source. Okay, so that saves the complete transmission of the bandwidth ಅಂದ್ಬಿಟ್ಟು. ಸೊ ಇಲ್ಲಿ 12 ಬಿಟ್ಸ್ ಅಂತಂದ್ರೆ 100%, ಅದರಲ್ಲಿ 3 ಬಿಟ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀರಲ್ವಾ. ಸೊ 3 ಬಿಟ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀರ ಅಂತಂದ್ರೆ ಆಲ್ಮೋಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಸೇವ್ಡ್ ದಿ 75% ಆಫ್ ದಿ transmission bandwidth transmission. So like this they are going to do the compressions under the ಯಾವ್ದಿದು differential encoding scheme. Okay, 12 bits ಬದಲು you are using only 3 bits. ಸೊ 12 ಬಿಟ್ಸ್ ಅಂತ ಅಂದ್ರೆ ಅದರಲ್ಲಿ ನೀವು 75% 25% ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಸೊ ಅಂದ್ರೆ ಅದರ್ಥ 12 ಬಿಟ್ಸ್ ಅಲ್ಲಿ ನೀವು 3 ಬಿಟ್ ಮಾತ್ರ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂತ ಅಂದ್ರೆ ಅದರ್ಥ ಏನು, ಓನ್ಲಿ 25% ಯು ಆರ್ ಯೂಸಿಂಗ್, 75% it is saved ಅಂತ ಅರ್ಥ. ಸೊ ಔಟ್ ಆಫ್ 12 ಯು ಆರ್ ಯೂಸಿಂಗ್ ಓನ್ಲಿ 3 ಬಿಟ್ಸ್. ಸೊ 3 ಬಿಟ್ ಅಂತಂದ್ರೆ ಓನ್ಲಿ 25% ಇಸ್ ಯೂಸ್ಡ್ ಅಂತ ಅರ್ಥ. ಇನ್ ಮಿಕ್ಕಿದ 75% ಸೇವ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ ಬ್ಯಾಂಡ್ ಬಿಡ್ತು. ಸೊ ಈ ತರ ಇರೋದನ್ನ ನಾವು ಡಿಫರೆನ್ಷಿಯಲ್ ಎನ್ಕೋಡಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. So this is also one type of the comparison principle. Okay, so this is about the differential encoding. So understood? ಗೊತ್ತಾಯ್ತಾ?
Yes, sir.
Okay, so next was transform encoding ಅಂತ ಕರೀತಾರೆ. So transform encoding ಅಂತ ಅಂದ್ರೆ transforming encoding, it is also one type which come under the so source encoding ಬರುತ್ತೆ. Okay, source encoding ಇಲ್ಲಿ ಬರುತ್ತೆ. There are two types, one differential encoding and transform encoding. Okay, so in the transform encoding what they are going to do ಅಂತ ಅಂದ್ರೆ the transforming encoding involves transferring the source information from one form to the another form. Okay, there is no loss of information associated with the transformation operation, and this technique is used in the number of the application involving both images and video. Okay, here where it is used antandre, it is used in case of the application, multimedia application that involves the images and video. Here they are going to convert the source information from one form to the another form, but there is no loss of information. So loss of information antandre, for example, if you take image ಅಂತ ತಗೊಂತು ಅಂತಂದ್ರೆ, ಸೊ ಆ ಇಮೇಜ್ ಅಲ್ಲಿ ವಿ ಹ್ಯಾವ್ ಸಮ್ ಪ್ರಾಪರ್ಟಿ ಅಂತ ಅಂದ್ರೆ ಏನು ನಾನು ಹೇಳ್ತಾನೆ, ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದಿ ಸೋರ್ಸ್ ಅಂದ್ಬಿಟ್ಟು ಇನ್ ಕೇಸ್ ಆಫ್ ದಿ ಇಮೇಜ್. ಸೊ ದೇರ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕನ್ವರ್ಟ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಇಮೇಜ್ ಇಂಟು ಅನದರ್ ಫಾರ್ಮ್ಯಾಟ್. Okay, if for example one format it uses some number of the bits, another format it uses some number of the bits. So like that, without disturbing the source information ಅಂತಂದ್ರೆ ಆಕ್ಚುಯಲ್ ಇಮೇಜ್ ಹಂಗೆ ಇಟ್ಕೊಂಡು, ಸೊ ದಿ ಫಾರ್ಮ್ಯಾಟ್ ನ ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡ್ರೆ number of the bit requirement will be changed. So if one format it requires some 20 bits ಅಂತ ಅಂದ್ರೆ another format will require 10 bits ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಈ 20 ಬಿಟ್ಸ್ ಜಾಸ್ತಿ 10 ಬಿಟ್ಸ್ ಕಮ್ಮಿ, ಹಾಗಾಗಿ ಇಲ್ಲಿ 20 ಬಿಟ್ಸ್ ಇಂದ ನಂಬರ್ 10 ಬಿಟ್ಸ್ ಗೆ ರಿಡ್ಯೂಸ್ ಮಾಡಿದ್ವಿ. ಸೊ ಅಂದ್ರೆ ಅದಾಗುತ್ತೆ 50% ಆಫ್ ದಿ ಬ್ಯಾಂಡ್ ವಿಡ್ತ್ ವಿ ಹ್ಯಾವ್ ಸೇವ್ಡ್ ಅಂದ್ಬಿಟ್ಟು. ಸೊ ಲೈಕ್ ದಟ್ ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಮೇಕ್ ದಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮ್ ಎನ್ಕೋಡಿಂಗ್. ಸೊ ಒನ್ ಫಾರ್ಮ್ ಇಂದ ಅನದರ್ ಫಾರ್ಮ್ ಗೆ ವಿತೌಟ್ ಡಿಸ್ಟರ್ಬಿಂಗ್ ದಿ ಸೋರ್ಸ್ ಇನ್ಫಾರ್ಮೇಶನ್. Okay, that is called as transform encoding, transferring the your source information from one source to one form into the another form without loss of any information associated with the operation. So this technique is used in the applications called as images or video. Both it is used. There they are going to use this transform encoding, transferring the source information into one form to the another form. Okay, that is called as transform encoding. So next, what they are done, the rate of change in the magnitude as one transfers the matrix give rise to term known as spatial frequency. So here they will analyze the some frequency, spatial frequency and analyze ಮಾಡ್ತಾರೆ. So what is the spatial frequency? Rate of change in magnitude as one transfers the matrix give rise to the term known as spatial frequency for any particular image. For example, if I consider the image, for any particular image, there will be mix of different spatial frequency. ಸೊ ಇಲ್ಲಿ ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ಅಂದ್ರೆ ಸೊ ಇದರ ಚೇಂಜಸ್ ಆಗುತ್ತಲ್ವಾ, ಸೊ ಅದನ್ನು ನಾವು ಫ್ರೀಕ್ವೆನ್ಸಿ ಅಂತ ತಗೋತಾ ಇದ್ದಾರೆ ಇಲ್ಲಿ. ಸೊ ದರ್ ವಿಲ್ ಬಿ ಮಿಕ್ಸ್ ಆಫ್ ಡಿಫರೆಂಟ್ ಸ್ಪೇಷಿಯಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ whose amplitude levels are determined by related changes in the magnitude of the pixels. So here they are going to analyze the spatial frequency of the image. What is frequency ಅಂತ ಅಂದ್ರೆ spatial frequency ಅಂತ ಅಂದ್ರೆ amplitude are determined by the related changes in the magnitude of the pixels. So ಇಲ್ಲಿ magnitude of the pixels change ಆದಾಗೆಲ್ಲ so changes now they are considered as a spatial frequency. So that spatial frequency whose amplitudes are determined by the related changes in the magnitude of the pixels. So that they are going to exploit. Okay, that is the source information property exploit anta. Okay, so they are going to make this property exploits. If we scan the matrix in either in horizontal or vertical, this in turn give rise to the terms horizontal and vertical frequency component of the image. So you'll not observe moduli. So they have taken one line here, okay, horizontal line with the vertical line. So each particular image some spatial frequency they are going to analyze. Spatial frequency and some difference in the amplitude level. Okay, so now the pixel amplitude level. Okay, ಇಲ್ಲಿ ತೋರಿಸ್ತಾ ಇರೋದು. So high pixel amplitude level and low frequency ಇಲ್ಲಿ low frequency pixel level ಅಂತ ತೋರಿಸ್ತಾ ಇದ್ದಾರೆ. So if you consider this as a continuous line, okay, so horizontal line and vertical line, okay, so here pixel amplitude, okay, low spatial frequency. So ಈ particular image ಅಲ್ಲಿ, okay, they are going to analyze the pixel spatial frequency. So low frequency ಅಂತ ಅಂದ್ರೆ ಈ ತರ, high frequency ಅಂತ ಅಂದ್ರೆ ಈ ತರ. Okay, these properties they are going to exploit. They are going to exploit this property. Okay, in case of the image. Okay, so here they have taken some image with the difference in the amplitude level. Okay, so ಅದನ್ನ ತಗೊಂಡು spatial frequency, low frequency ಮತ್ತೆ high frequency ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ. Okay, so ಈ ಪ್ರಾಪರ್ಟಿನ they are going to exploit. Okay, they are converted this property into the one form to the other form. So ಹೇಗೆ ಮಾಡ್ತಾರೆ ಅಂತ ಅಂದ್ರೆ the transformation of these 2D matrix of pixel value into the equivalent matrix of the spatial frequency component can be carried out using the mathematical technique known as discrete cosine transform. Okay, yeah, they are going to use the mathematical technique to convert this source information into the another form using the technique called as discrete cosine transform and use this they are going to use this matrix. Okay, this spatial frequency, low frequency, high frequency, amplitude levels. So these are all the things they are going to take in the matrix. So this matrix they are going to using this matrix they are going to convert the image into the one format to the another format. That is carried out by mathematical technique called as discrete cosine transform ಅಂತ use ಮಾಡ್ತಾರೆ. So DCT. Okay, it is used in image processing. You are going to see this DCT, discrete cosine transform ಅಂದ್ರೆ ಅಂದ್ಬಿಟ್ಟು they are going to see in the image processing area. You are going to see in detail what is a discrete cosine transform. It is on matrix form. Okay, that matrix form will be taken out by this spatial frequency, amplitude level, range matrix na ತಗೋತಾರೆ. ಆ matrix na substitute ಮಾಡ್ಬಿಟ್ಟು they are going to find out this discrete cosine transformer that is carried out by the DCT. Okay, so how they are going to transform ಅಂತಂದ್ರೆ so ಈ ತರ discrete cosine transform mathematical technique use ಮಾಡ್ಕೊಂಡು they will take this matrix and they will convert it into another pattern. So ಅದನ್ನ ನಾವು form ಅಂತ ಕರಿತೀವಿ, conversion of the image into one form to the another form. So this is called as transform encoding ಅಂತ ಕರೀತಾರೆ. ಗೊತ್ತಾಯ್ತಾ? ಹಲೋ,
Yes, sir.
So this is about the source encoding. Source encoding ಅಲ್ಲಿ ಎರಡು ತರ ಇದೆ. One is differential encoding, ಇನ್ನೊಂದು ಇನ್ನೊಂದು ಯಾವುದು differential encoding and transform encoding. So source encoding ಅಂತ ಅಂದ್ರೆ source is taken, property of the source is they are going to taken out. Okay, so next we have studied statistical encoding or run length encoding. So this is one type, entropy encoding and source encoding. So these are the compression principles. So next we have text compression ಅಂತ ಇದೆ. Okay, text compression ಅಂತ ಇದೆ. So this you can see in next class ಅಲ್ಲಿ ನೀವು ನೋಡೋಣ. Okay, we're going to see in the next class.